This is Algebra 2 with trig, 1b.3. We're working with quadratics in standard form. Vertex form, which we've done in the past. Intercept form, which we've done in the past. And today we're going to talk about standard form. ax squared plus bx plus c. Notice that standard form is different than intercept form. It has different variables. It doesn't have any parentheses, but it does, of course, have a term that is squared. So we're going to take this intercept form and we're going to convert it over to standard form. So you want to think about, how would you do that? What do you need to do? We need to multiply the two parentheses together. So some people would call that FOIL. May have learned that in Algebra 1. FOIL is when you multiply the front two values in your parentheses. O would be the outer two numbers in your parentheses. I would be the inner, and L would be these last two of each set of parentheses. Another way to think about it is you take the x and multiply both terms in the other parenthesis. You take the 2 and multiply both terms of the other parenthesis. It would be like double distribute. But we would get x times x is x squared. X times 5 is negative 5x. 2 times x is positive 2x. And 2 times negative 5 is negative 10. So if you notice here, you have like terms. Our like terms are our x's. So we can simplify this down still. X squared minus 3x minus 10. You can't lose the parentheses. The parentheses are still important. It's 3 times this amount. We multiplied it together. Now we're going to multiply it by 3. So we get 3x squared minus 9x, because 3 times 3 is 9, and 3 times 10 is negative 30. There is your standard form that matches your intercept form. The table that this creates is the same table that the intercept form creates. The graph that this one creates is the same graph as that one. Let's give it a try. So I'm going to type in, first we're going to do second plus 712, so we can clean our calculator. We had 3 times x plus 2 and x minus 5. So that's our first equation. If we go to table, which is second graph, the y values are the values in your table. Now if I go to my second equation, y2, I can type in the new equation, 3x squared minus 9x minus 30. So it looks very different. Doesn't look very similar there. The A is the closest thing that matches. But when I go to the table, you can see that all of the numbers match exactly. Okay? If you try graphing this, if you hit graph, you won't be able to tell where the one graph is and where the second graph is, because they're exactly the same graph. This is kind of a cool step. Hit y equals. You can go to either equation. Probably go to the second one. Move your cursor over to the little line and hit enter once. And you'll see a bold line. So it's going to graph the first equation, then it's going to graph the second equation with a bold color. There's your first equation. and then the second one comes through darker than the first. So you can see that it's overlapping. You can see when it went through the calculation. So that's converting intercept form into standard form. Let's slide over to vertex form into standard form. I would encourage you to pause the video and work yourself through this. There's a few mistakes that can commonly occur. So go ahead and try that. So pause the video. You try to convert this into what we've learned to be standard form. Okay, let's give this a try. Some common mistakes. One of them is thinking that you can distribute your negative in, but this is squared, so you don't really have x plus 2. So you can't say that this is 5x and 10 or negative 10 because this is squared. You cannot distribute the square through either. You cannot call this x squared plus 4. That's a very common mistake. What we need to do is write it twice. X plus 2 and x plus 2. And don't forget your 8 on the end. You must write the parentheses twice. It will not work otherwise. Now we're going to go back to that FOIL. The first, the outer, the inner, the last. So this is negative 5. X times x is x squared. Now you can speed this up if you want. X times 2 is 2x, and 2 times x is 2x. So that's a total of 4x. And then 2 times 2 is also 4, with your 8 on the outside. Don't make the mistake and think that the 8 goes with the 4, because that's not a 4. This is 5 times 4. So you have to distribute the 5 through there. And we get negative 5x squared, negative 20x, and negative 20. Now we don't need parentheses. We've used the parentheses. Negative 20 and 8 can now be worked with. And of course, that's negative 12. There's your standard form. There's your vertex form. When you look at standard form, take a good look at that. Do you see the vertex in there? Do you see negative 2 comma 8? The answer is no. You don't see negative 2 comma 8. This is not showing you the vertex. You cannot look at this and know the minimum value, the maximum value. A lot of people are going to tell me that this C value is your minimum or maximum value. Nope. You know that your maximum value is 8, not negative 12. So you got to do some calculations to determine that. So that's where we come into discussing how we use ax squared plus bx plus c. This is a parabola. We know that because we have x squared. X squared is quadratic. And a quadratic creates a graph that we call a parabola. It's a U shape. That's a parabola. We have a line of symmetry that runs through the center, just like we have in our other ways that we did quadratics. This time we use x equals negative b over 2a. That is our line of symmetry, our axis of symmetry. What's on the axis of symmetry? The vertex is on the axis of symmetry, so it's the x value of the vertex. So the x value of the vertex is always negative b over 2a. Now, I've been saying negative b. Maybe it's better to call it the opposite of b. Because if b is a positive, it becomes negative, and if the b is a negative, it becomes a positive. It's the opposite of b over 2 times a. The y-intercept, where does that occur? A y-intercept is where the parabola is crossing the y-axis. What's the value of x on the y-axis? Of course it's 0, because it's not to the right at all, it's not to the left of all of the origin, it's right across vertically on the y-axis. So all the points here have to have an x that is 0. So we call that 0. And if you plug in a 0 into your equation, 0 squared makes 0. B times 0 makes 0. And you only are left with C. So you're always going to get the C value as the y-intercept. The y-intercept is not where the vertex is at least not all the time. It's possible, but not all the time. It's only where the parabola crosses the y-axis. That's the C value. You already know about the A value. We've done this many times. It opens up when A is positive, and it opens down when A is negative. So when we talk about max and min values, we've discussed those using our different forms of quadratics. So you should be pretty familiar that we get a minimum value when A is positive. There we have the A is positive. If I trace out the graph, you see that it is opening upwards, but it has a low point. Here I'm tracing out the graph, and it has a high point. This is when the A value is negative. This is when the A value is positive. So you have a minimum with A value is positive and a maximum when the A value is negative. So we can come down here and practice that. Here's our quadratic. Let's slide over to this one first. Let's do this one first. Here's our quadratic. Can you tell me which one of these do we expect the graph to look like? Is it going to have a maximum value? Is it going to have a minimum value? It should have a maximum because the A value is negative. So what we're going to try to do here, essentially we are going to find the vertex. So the first step we're going to do is calculate the line of symmetry, or you could call that axis of symmetry. And we use x equals the opposite of b over 2a. My b value is positive 12. So the opposite of 12 divided by 2 times a. So that is negative 12 over negative 6, and that comes out to be perfect 2. That's nice. Line of symmetry is 2. Now we're going to plug it back in. So our x value for the line of symmetry is 2. So we're going to say negative 3 times 2 squared plus 12 times 2 minus 6. Now, how do you do that? Many mistakes happen here when people multiply the 3 and the 2 first. This is not 6 squared. You have to square, use the exponent first. You have to square the 2, then you multiply that to the 3. So this becomes negative 3 times 4. This becomes 24, and you still have the 6. Which makes this negative 12, and this would become 18, which is a total of 6. Negative 12 plus 18 is 6. Either way you look at it there, that's going to come out to be 6. And because the a value is a negative, that will have a maximum value. Notice my answer is not the vertex. The vertex is 2, 6. But my maximum value is just 6. Don't include the 2 with your maximum value. So that was a nice one. That's why we wanted to do that one first. This one is a little trickier. We do it the same way. We're going to use negative b over 2a. So we're going to do the opposite of b. So the opposite of negative 6 over 2 times 2. So that gives me 6 over 4, and that can be reduced into 3 over 2. That is my line of symmetry. So yes, now you understand if we have a fraction as a line of symmetry, then we'll be plugging our fraction back into the regular equation. So 2 times 3 halves squared minus 6 times 3 halves plus 8. Now it's tempting to use a calculator here, but you can do this. Don't be afraid of your fractions. We have to work with the square first. Please excuse my dear Aunt Sally. There's nothing inside the parentheses we can do, but we can work with exponents. So when you square a fraction, you're writing it twice. You're thinking about it as, we can write it twice. 3 over 2 and 3 over 2. That's what that means. Reinforce that idea. How are we going to multiply this? Negative 6 times 3 halves. How does that get multiplied? We've done it many times before. We're going to place a 1 over the 6, or I guess a 1 under the 6. Place a 6 over 1. We're going to multiply the top numbers. We're going to multiply the bottom numbers. It's not an equal sign, sorry. That is minus 18 over 2. 6 times 3 is 18. 1 times 2 is 2. Notice there was no common denominators. We don't need to do that here. Then we have 2. 3 times 3 is 9. 2 times 2 is 4. Minus, this is 9, right? 18 divided by 2. No need to make common denominators if I can reduce that. Plus 8. All right, how do I simplify this? We just did it. 2 times 9 and 1 times 4. So this is 18 divided by 4. These two numbers make negative 1. You might want to simplify this to 9 and 2 so we don't have to simplify it later. But what value of 1 am I going to use? What value of 1? I'm just going to use a 1? Or do I need to have common denominators? If I need common denominators because I'm subtracting, and of course I do, what numerator am I going to use? Two over 2 is a value of 1. So that becomes 7 over 2, and that is considered a minimum because our a value is positive. There it is. That was trickier, no doubt about it. But they're not all tricky. We saw an easier one right here. Okay, let's flip over. Let's talk about some common misconceptions. This equation right here, 5x squared minus 7, it's supposed to be an easier question. It has less numbers in it. But people often get a little confused. So what form is that in? Lots of people might call that standard form. And if that was standard form, f of x, you could say that you have 5x squared and you have 0 of the b's and you have negative 7 for your c. So a is 5, b is 0, c is negative 7. That would be standard form. Is there another form it could be in? We only have 3 options. And the other one would be vertex form. And for this to be in vertex form, you might like to see it written as 5 parenthesis x minus 0, because there is no value being subtracted from the x. There is no h, squared minus 7. There's your vertex, 0, comma, negative 7. So to find your vertex, you can look at your h and your k. So this is supposed to be an easier one to find the vertex for. But people get confused that there's no b, you don't know how to do negative b over 2a. If you treat that as negative b over 2a, it works out just fine. You get 0. So your line of symmetry is at 0, just like we said it was. Then you can plug the 0 back in, and we get 5 times 0 squared minus 7. This becomes 0. F of x isn't a great term to use. I'm sorry. Let's just make that y, because it is the y value. All right, the y value would be negative 7. So we get 0, comma, negative 7 when we plug our b value of 0 into our line of symmetry. A little bit more complicated looking, but that's this form. What's different about this one? So what form is this in? This one has a square in it, so we know that it's not intercept form because it has a square. So we would say that this would be standard form. Our f of x would equal x squared minus 4x and nothing else. There is no c value. You don't need to write it with a 0. That would probably get more confusing. I wouldn't write it with a 0. I'm just showing you that that's the values of a, b, and c. A is 1, b is negative 4, c is 0. How could we turn this into intercept form? We can pull the common term out. See, there's a common x in both of them. So we can take our f of x, pull our common x out. That's going to leave us with an x minus 4 left over. This would be considered vertex or intercept form. If you like to think about it as a 0, then you're totally confident that it has a y-intercept of 0 and a y-intercept of 4. And that's how we did that. So those are supposed to be easier formats. But a lot of times people get confused. So stay focused on what you know.